Well, hello there. Welcome to AP Statistics, Section 4.3b, Notes. I hope you're having a great fall break. And we're going to talk today about inference. And anyway, I'm sorry. I don't know. I just wanted to use this today, but we are talking about inference. We're going to get into inference today, and I want to get into the podcast. Before I do, just a couple of announcements. Make sure, if you could, you have some time, get a little bit of that homework done. If you don't, that's fine. Just know that it's going to be due on block day by midnight. The first 10 to 15 minutes in class we'll give for homework. So let's do this thing. Let's get through it. Hey, before notes, though, while I'm getting this up, if maybe you pause the video, I want you to try to go through the following just to identify whether they were a random sample or a random assignment. So simply put yes or no for whether it was a random sample and a random assignment, and just put them there and identify what's going on within that specific section. So if you unpause me now, we're going to go in through the scenario and then the questions, and then we're going to propose some inference, the holy grail, as you would say, for this specific solution or situation. Here we go. It says, some students at your school claim that listening to music while studying will help improve their GPA. We're designing a specific study. Really, we're not designing it. You're going to see that each situation designs it for you. We're trying to find the inference based on that. All right. So there's 4 proposed studies, each investigating the question of the day. Now, each one, this is important, we're going to suppose that the mean GPA of students who listen to music is significantly lower. So we already know the results. We're giving it to you. And we're going to see whether, and then it also says significantly lower than the mean GPA of students who didn't listen to music. So the conclusion is what could we make based upon how we design each scenario? And it really is based on the scenario of how we designed it as to what we can infer, and that's what we're going to look at here. So let's take a look at this here. Scenario number 1. Again, the same result for each one of them, right? So increased GPA for those that listen to music and decreased GPA for those that didn't. All right, here we go. It says, get all the students in your stats class. It's important, all of them, right? To participate in a study. Ask them whether or not they study with music on, and divide them into 2 groups based on their answer to the question. Again, remember that the conclusion is already there in terms of the fact that those that did listen to music would in fact have a higher GPA. So we're assuming that for all 4 scenarios. So just remember that. Now, if we had that same conclusion for all 4, the question is what inference can be made? And this is really a good activity to kind of pull everything together. All right, so let's look at it. First of all, was there a random sample that was there? The answer was no. We had no random sample that was taken from my population. The next question, I'm going to get a different color so you can see this a little bit better here. Let's do this. Perfect. Was there random assignment? The answer was no. Okay, so if there was no sample and we didn't really randomly assign, the question is what is our conclusion? Well, the only conclusion that we can make is for the students in this class, we can say that there is a correlation. Can't really infer much. We could say that there's a correlation between music and their GPA. Listen to music while studying, I think, is what the overall thing was. So let's put that in now. While studying increases or and lower GPA. Oh, I'm sorry. I kind of backtracked. My fault. We're saying that listening to music will lower. Okay, let me say significantly lower. There we go. Okay, so we're lower. So that's where I kind of went off. Music while studying. And here we are. Lower GPA. We can't say cause, right? Can't say cause. we could just say that there's a correlation. So if there's no random assignment, there's no random sample, we get the data and we just say that there's a correlation. So what can we say about number one? Well, we're going to come back to number one, and I'll kind of piece it together to show you the differences here. Number two, select a random sample, that's huge, of students from your school, population of the school, participate in a study and ask them whether or not they study with music on, and divide them into two groups based on their answer to the question. Again, those that listen to music would have lower GPAs, right? We've already know what would happen after the study. The question is what can I conclude? Well, the random sample was a yes, but there was no random assignment. I didn't assign anything. So what can we conclude? Well, we can say for all students, again, we got the same result, so that we didn't actually get it, but you know where we're at. For all students from the school, that's the population, there's a correlation between listening to music while studying and lower GPA, right? So there's a correlation between listening to music while studying, and lower GPA, okay? Excellent. So the reason why I only can say correlation for both is because of the fact that there's no random assignment going on, right? And because of that, I can't say that there's a cause and effect relationship. And so we're going to look at what the inference would be within a random sample, maybe the difference between these two. Notice that I only can talk about really the difference is within a random sample only from the school down here with the yes. I can't have inference, but I can correlate the students that I took from my population. And so the yes allows me to say it to the whole school, where up above here, I only can say it to the statistics class, right? Because there was no random sample that was created. I only can say it for the people that were chosen. Whereas down below here, because it was random, I can only say that it correlates to students within the school, because that's what I drew my random sample from, right? So that's what we can correlate there. Number three, get all students in your stats class to participate in a study. All right, let's see what we got. Randomly assign, okay, here we are. Half of the students to listen to music while studying, and half of the remaining abstain from listening to music while studying. We would compare, and again, the result would be the same. Listen to music while studying would decrease their GPA, which brings some ethics into it, but we're not going to go there right now. We'll get to that in a second. So the question is there a random sample? The answer was no. There was no random sample. Those that were in the statistics class were the ones that were there, right? Everyone in the statistics class. Was there a random assignment? Yes, there was. So the conclusion, well, we can just say only for the students in the class, right? Because that was what I took from, right? That's what I took from. For the students in the class, we can infer that listening to music while studying decreases or lowers GPA, okay? All right, and that's important, okay? And really, when we say infer, maybe this would be better because this is really what we've been talking about. For the students in the class, we can infer that listening to music while studying causes, because this is a cause and effect, right? Causes a decrease, maybe that's better, in GPA. Because this is a cause and effect. Why? Because the random assignment, there's power in experimental, right? Really, this is experimental, whereas this is observational, okay? Now, sometimes this can kind of have a play where an experiment could also have a random sample. And we really haven't looked at this yet because we've said that it's kind of in both worlds, but sometimes it does bleed over. So let's go through our last scenario. Select a random sample of students from your school to participate. Now, this is where you think observational, but before we make that, let's make sure we go into this. So this is a yes, right? It says randomly assign half of the students to listen to music while studying for the entire semester and have the remaining half abstain from listening to music while studying. Because we took the random sample from the school, we are able to infer our cause and effect relationship to the entire population of the school. Whereas up here in number 3, we only are able to talk about the statistics class because there was no random sample that was taken. And so for the students in that class, we can infer that there. But this time we're going to say it a little different. So we say for the students in the school, we can say that because we took a random sample, right? And then we randomly assign. And this is experimental here, okay? Yes, I know random sample, we've said that's observational, it's true. But sometimes random samples are used to be able to allow us to then randomly assign those random samples to 2 different categories. In that case, it would end up being an experimental. For the students in the school, here we go, we can infer that, again, same result, that listening to music, we get the same result, right, to music, while studying causes a decrease in GPA. Okay? And that's important. That's important to look at. That's important to know. So as we go back here, let's just talk about this real quick. These are kind of the golden nuggets. So get these down on the side, but highlight them, okay? With no random sample and no random assignment. Well, let's look at random sample first. If this is a no, right? We cannot infer anything outside of what we initially sampled, right? If we don't have a random sample that was taken from a population. So because of that, we can't go any larger than this. We're just going to say no inference about population. Okay? When we do randomly sample, like down here, we are able to say, yes, we can infer to the population, or use inference to the population, okay? When we randomly sample. Because we randomly sampled from the school, we can say that whatever a random sample was here, that it actually is a representation of the entire school, which allows us to have inference. Actually, bad word, because we can't infer here in this example, right? But it allows us, well, yeah, infers to the population. We can't say cause and effect here, okay? Remember why? Because this is a random, not a random assignment, we can say no cause and effect here. That's why we can only say that there's a correlation to what? Just the students that we saw. Now down here, because we randomly sampled, we say students from the entire school population. But there's only a correlation here because there was no random assignment. So again, just down here, we say no cause and effect. That's important. Okay, let's go to the next one. The next one says no random sample. So we could say no inference to population, but with a random assignment, we could say that it, yes, we can infer cause and effect, right? So we only can have, we'll have inference to cause and effect with just the people that we sampled, right? Just to the statistics class. I can't go beyond that because there was no random sample taken. I'm hoping this makes sense here, okay? Let's go to the last one. Is there a random sample? Yes, there is a random sample. So because of that, we can infer to the population, which was the school, right? Because a random sample was taken. But we don't say observational yet because when we keep reading, we then see that it was randomly assigned, which allows us to infer cause and effect, right? The amount of music listened to while studying impacts or causes a decrease in GPA. And so this one actually allows us to infer to both the population, the school, as well as the fact that whatever we're looking at, in this case music, causes a decrease in GPA because it was randomly assigned. So this again allows me to know that it's experimental, Whereas the other ones, where there were no random assignment here, this would be more of an observational. This is an observation study, okay? So this would be observation. All right, good. Let's take a look at one more thing, and then we will continue. Last little bit here. Number one, let's talk about this. This is inference. Some of this may be a review of what we just said. Let's talk about inference. Random sample. So if we want something that's just like, okay, what do we say about a random sample and a random assignment, okay? What do we say about each? Well, let's take a look at this here. Within the red one, I'll put it down here. This allows us to generalize to the population, okay? Let's say an example would be, let's say we take a SRS, simple random sample from Gwinnett. Whatever we find, we're able to correlate only if this is a yes. Now, randomly assigned to, that's different. But if we just, with no random assignment, we're able to correlate whatever we find to all of Gwinnett County because the SRS is from Gwinnett County, okay? So it generalizes to my population. Random assignment allows us to use cause and effect relationship, okay? So in an ideal world, if we take a random sample from my population and then we randomly assign that sample, we're able to not only generalize to my population, but show cause and effect to that population. That's the power. Okay, that's the power. I got the power. That's the power. Okay, number two. Last thing, and then I'm done. Data ethics. Just a couple things to note here. It doesn't really have to go into too much detail. But real quick, you need to really be ethical in institutional review. A couple things that we've got to have in order to really, when we post, especially when we post data to databases and that sort of thing, we need a couple things that really kind of are some backdrops to really help us in being ethical in the way we collect data, the way we approach data, and from there. So number one is, and I'll go backwards here because it's easiest to kind of tell this. Confidential. You need to have something that says that, hey, the information that I'm getting is confidential and it's anonymous. Okay, so or if I know who it is, I can compare that, but I can't post names or anything like that. That was huge in my specialist. I wasn't able to post names. I had to be very, very careful with what I posted on there. Okay. The second thing is I must have consent, especially those that are under 18. 18-year-olds or older are able to sign their own consent, but those that are under 18 have to have someone else that signs for them. So I have to have informed consent. That means that whatever I'm posting needs to be reviewed by someone else. It's not just me going rogue and just making things up. So they need to be able to review it to make sure that what I am saying, how I am inferring from my population, is in fact accurate. Okay, and it's important about what's going on there. All right, here's something too, randomly assigned, right here, and individuals who are randomly selected. This is a random sample. This is our randomly assigned. You kind of can see this. It's a good box just to kind of refer to when we talk about inference, about population and cause and effect, which we just talked about. Hey, real quick, pause this video, try this one out. If you could bring this to me on block day, I'm not going to ask for it, but if you could bring this to me block day and just show it to me, I'll give you 2 tickets on that. I've run out of time. I'm seeing if I have that answer sheet. I don't think I do. But bring it to me. If you do have questions on it, let me know. But bring it to me done, and you'll get 2 tickets on that, and I'll get that to you. Cool? All right. Hey, we're signing out. I hope you just have a great fall break. I really do. Care about you. Love y'all. And let's keep pushing. We're getting one day at a time. Better today than yesterday. Hey, love y'all. Hey, real quick, on the out. Let's see if I can hit this shot. You ready? Here we go. Oh, close. Oh, all right, here we go. This shot. Ready? Oh, very close. Hey, have a phenomenal day. We are live. Hope you have a good one. Bye. Trying to stop it. Trying to stop.